Hello, and welcome to this discussion about building automation networks that use LonWorks. Your presenter today is Michael Morsfelder. I'm a senior HVAC application engineer at ABB, and I've been in the drives business since 1981. This presentation will cover networks that use the LON platform for building automation. The information about the LON network will be presented in a LonWorks 101 type format. To accomplish that, I'm going to start with LonWorks definitions. We'll bring up the unique LonWorks properties that the network offers. And then the fun will start by creating a LON network. It'll be a real LON network that I've created. We're going to add a device to that LON network. We're going to commission that device. And then we'll see the finished product, and we'll see what conclusions we can draw from this discussion about LON. To start the discussion, I'll ask the question, what is LON? What is the big deal with LON? And the answer is, LonWorks is an open protocol introduced by Echelon in about 2008, and it was the first open protocol for building automation systems. Now, Echelon Company has LonWorks, but they have it in several different configurations for different industries. So the one we're going to talk about is identified as FTT-10A. There won't be a test on that later. It's just a statement that says LON is available in several configurations. And like many other networks, there are standards that all manufacturers have to comply with. So LON has developed this LON Mark Association, and they're, I guess I call them the governing body. And when you manufacture a product, you have to meet all their standards. Now here, the focus will be on the unique characteristics of LON in comparison to other HVAC or building automation protocols. Just a note for reference, if you want to get a good series of definitions and a good overview, the LonWorks system is discussed in Chapter 3 of the FLON manual. With that brief introduction, let's jump right into LonWorks definitions. Before I start, I'd like to set some realistic goals for what to do with those definitions. The goal isn't to get you to memorize all of these different terms. Rather, the goal is, what do these things mean in context? You may have heard of some of these terms and not really understood what they mean. So let's get started on defining LonWorks. LON is a local operating network, and that's the Echelon definition. They further define things as a network that consists of nodes communicating using LON talk protocol, and we will cover that in more detail shortly. As a testament to the power of the network, it can consist of up to 32,000 nodes, and they divide that into subnets and how many nodes per subnet. I don't think that's overly significant other than the fact that it can handle 32,000 plus nodes. Now, LonWorks, the term we hear the most, is the general term that's applied to all things LON. And again, that's the Echelon definition, not something that is made up. LON talk is defined as a twisted pair transformer isolated free or open network that operates at 78 kilobytes. Wow, that's a mouthful. Now the next two definitions are a little more uncommon to users. They refer to the tools that Echelon, the originator, has made up for network configuration. So you may have heard the term LON Maker, and that's their original tool, which has been replaced by Izot CM, just a word that defines their new commissioning tool. Now there are other network configuration tools out there. I'm just using the terms that Echelon has set up and uses in their literature. They also use a term called LNS, which is pretty obvious in the fact that it's LonWorks Network Service. And I don't see it as much as I used to, but the term is used in context of how you set things up and configure your network. The next couple of points, or definitions rather, I'm not going to go through in a lot of detail because they began the definition of different variables. The important part is that The first definition is for network configurable inputs, and we will cover that shortly, and we call them NCIs. They have another definition, and like other networks, that's where they have network variable inputs and outputs, and then they break that down further into switches, levels, and counts. I don't need you to memorize that. I just need you to be aware that as you go through, say, for example, the LonWorks manual, you're going to see these terms used, and I just want you to be familiar with them. As we continue our LonWorks definitions, I'm introducing a few photos of the FLON 01 module. I'll use these pictures to illustrate the four main terms or functions in the world of LAN. And we're going to start with the service pin. You may have heard the term pinging or pinging the network. What that means is that someone manually presses the service pin to broadcast the neuron ID to the rest of the network. Now, in some of the newer networks, an auto discovery function is available, which would kind of make the service pin obsolete. However, the Echelon tool does use a service pin as their format for commissioning, so I'm going to continue using it in this presentation. The neuron chip. Ah yes, this is the Echelon proprietary processor. These chips are identified as 3150 smart chips in LAN documentation. And what's extremely important to know is that we talk about this neuron ID number. It's not really printed on the chip, but it is programmed in by Echelon as one in the world. Then there's the transceiver. The transceiver is defined by Echelon as a proprietary isolation transformer. And a really good example of that is the model FT-X1, which I've sort of highlighted with a little box around it. This is an important part because it literally connects the rest of the network to the module. And then the last term that you probably have heard is chipset. It's not really a legitimate LAN term, and you won't find it at all in their literature. But what it is, it's a common way of understanding that we have a processor chip and we have this isolation transformer, and together those make up the quote chipset that everyone has to buy from Echelon. When we look at networks that use LAN, we can find several unique LonWorks properties. So for this discussion, I'll concentrate only on the differences between LAN and other HVAC protocols, such as Modbus RTU or BACnet MSTP. And the first observable difference kind of stands out is the wire type specified. Normally, or maybe typically, a 485 network is required to use shielded, twisted wire pair, and it could either be 2 wires and a shield or 3 wires and a shield. However, Echelon introduced LonWorks or LAN Talk with a requirement for unshielded but twisted wire pair. And as you might expect, there were some noise issues in early application sites and maybe even into the first few years of its operation. But over time, Echelon refined their wire specifications and added several types of shielded wire to the list of things that you're allowed to use. In addition, there are several other network differences that stand out. The first one is that there's no wire polarity when you connect to the network. No plus, no minus. That kind of puts people back a little bit. Then there's this neuron ID we talk about. It is a unique network address. That number, somewhat like a MAC ID, except it's pre-configured into the smart chip by Echelon long before we get it. And because of that, there's no node ID or device, address, or any network ID information to enter. And, bonus, there's no parity that you have to set up either. And there's one other interesting difference between LAN and the others, is that they have a group of things or variables called NCIs. What that means in English is that these sets of variables can only be accessed by a network tool, not by the device as LAN calls it, in this case the FLON. You can not access those parameters or change them in any way looking at the drive. So what does this all come down to? Well, as just a point of observation, Indeed, LAN is different than other open protocols, but it still shares a lot of common network ideas. And some say that it could be seen startup as much more plug and play because of the Neuron ID situation and less work at startup. The discussion of networks that use LAN has been pretty basic so far. We've covered a few of the definitions, we've covered a few concepts, although not very deeply, and thrown in a few pictures just to get you somewhat familiar with the FLON module. However, the next logical step is to be able to understand what LAN tools will be required. And I think I can break it into two categories. The first category is pretty similar to other networks in the fact that you need some kind of an adapter to go from a USB port to LAN. And Echelon calls theirs an FT-PT-10A. And here's a picture of their adapter. As you can see, there's simply two-wire connection on one side and a USB port on the other that can plug directly into your computer. The other tool is a bit more intimidating, and that's the network tool. I'm showing you a network tool from Echelon called Izot CT. That's just the name. However, many networks don't use the Echelon platform. Instead, they use a different program called Niagara. It's not good or bad, but it is very common in North America. Now comes the fun part of this presentation. We're going to actually create a LAN network using the official Echelon Izot commissioning tool. So it kind of makes sense that a prerequisite is that both the Izot program from Echelon and Microsoft Visio are installed and working correctly. Let me just explain that for a moment. Echelon builds their program using Microsoft Visio. So you can purchase it from Echelon with the Microsoft license, or if you already have Microsoft Visio installed on your computer, then you just buy the program. And you start the process making sure that you've plugged in your network adapter, the FT10, into the PC, and that you've wired from that adapter to the actual device you're going to install and commission, in this case the FLON 01. And once those pieces of the puzzle are in place, you can start the commissioning tool. That means you go into your Windows menu, you find the CT icons, and you press execute. This is the first screen you're going to see. It's going to ask you to put in a network name that you're going to call it. And so for this experiment, or this presentation anyway, we've called it LNS1. And once you've entered that data, you can press the button that says Create Network. That'll bring up the next screen, which looks like this. The network name is carried over, and your task here is to actually either browse, or you might have a predetermined location for both the network, where the database is going to be stored, and where the drawing that's created in Visio are stored. Once those are identified, you can again press Next. The next step in creating our LAN network is to select and then name the network interface that we're going to use. Now in my case, I use the FT10, and as you can see in the screen capture, I've attached it to my PC, and the tool has identified that it's attached, and I've called the item LAN1. And why that's important is because the unique Neuron ID that's in my adapter is now associated for everything on the network as LAN1. Go ahead and press the next function, and then the next aspect of this is to set up how device changes are transmitted, or when they're transmitted to the network. As you can see here, the selection for OnNet has been checked. What that means is that when a change takes place, that change, like accel rate or decel rate or whatever it might be, is immediately sent to the network and put in play. Once you make that decision, go ahead and press Next. The next step in creating our new LAN network is a very important part of the process when you're using the Echelon commissioning tool. We must make a choice to register all new plugins. Whenever a new device is added to the network or plugged in, the image or the profile of that device is added to the network definitions. And so we have to choose to register all new plugins. In fact, this step is so important that the new network cannot be created until this command has been selected. Now, once it's selected, go ahead and select Finish. As we move on to the final step, pressing Finish starts the process of actually creating a network and a network drawing. As that network is being created, a status box pops up and it gives you the name of the database that it's creating. Now, once that network is complete or built, a network diagram is displayed, and the display is built again on Visio. So at this point in time, we have been successful in using our FT10 interface device, and now we have a channel open. At this point in creating our LAN network, the next logical step is to add a new device or a new node. I'll be adding the FLON 01 or LonWorks module to our network. To clarify that a little bit, the FLON module can be used on a variety of different VFD models and configurations. But for simplicity, I'm going to add the FLON device and show it simply as an ACH580 plus Eclipse. And that's because that's the model and configuration I used to create the presentation. However, the process, as shown, applies to any VFD that the FLON will support. And in general terms, it applies to adding a device to the network anytime we're using this Echelon tool. Now, I've previously mentioned that the Echelon network tool is built on a Visio platform, as seen on the right. And in the drawing tools area, Echelon has added some Izot shapes into the Visio as a way to build their network. Now, other LAN systems don't use this Visio platform. They have their own tool. And as an example, a number of the LAN BMS tools in North America have used the Niagara platform, or backbone, if you will, to build their network and their network tools. For our illustration purposes, we're going to start in Visio by selecting the device and dragging it. We click on it and drag it into the network drawing, and we're going to drop it just to the right of the network interface. And as soon as we drop that device, a new device wizard pops open. As the shape is released, a new device wizard opens, and our device 1 is shown as highlighted in blue. So the next step is to create a new device template, and then we have to commission the device, even though we haven't given it a name yet. So with those two boxes checked, press Next. In this step, we start to identify the unit and create a template. We start that process by entering the name of the device into the text box. Then we're going to have to create a new template name. And that name is going to carry on for the rest of the network. And anytime you add this type of a device, you simply select it, which we're not going to be able to show today, and add the appropriate title. In this case, I'm showing you that I'm adding, in place of ACH580, I put in AHU7. And that may be appropriate when you set up the first device. The purpose of the template is to actually give the network a template to use as many times as needed. Now, the next step is very critical. We have something called an XIF file, which really is the image of the new device. And we're going to select where that image comes from. We're going to select Upload from the device for our external interface definition, or XIF file. And once we do that, we are ready to get the unit commissioned. So to create a new template and the new device, press Next. This is my favorite step of the entire process. That's because this screen or this step requires no input whatsoever. You simply press Next and move on. With our network and our network diagram created, we introduced the device, we named the device, and we created a template for the device. So now we have to do the next logical step, which is to take the name that we've given that device and associate it with a specific hardware or a Neuron ID chip. Now there's several ways to get that ID number into the network. One way is that I could select the manual function and type in the Neuron ID if I happen to know it, or maybe it was printed on the box, but that's not very typical. And some building systems have an auto discover feature that basically asks the network who's out there, and whatever Neuron IDs have not yet been used or assigned pop up, and then we can go from there to identify the unit and marry it up with a specific object. However, the Echelon tool sort of leans towards using a service pin, so that's the method I'm going to use as we go through the rest of this presentation. It's as simple as it sounds. You simply select the service pin and press Next. Pressing Next will bring up a new information, or in this case, a command box, and the command is very straightforward. Go push the service pin. The illustration on the right shows the location of that service pin on the FLON 01 module. And during the time that you're waiting to press that, the network commissioning tool will show you a little hand there that alternates its position. As soon as you press the service pin, it will start initiating the action, and you'll hear a short ring sound, kind of like an old telephone. And the service queue message box will be displayed, and the blue lines will rotate around, showing you that it's in the process of identifying that particular Neuron ID. As soon as the network has identified this new object and its Neuron ID, it's included on the Visio drawing. And as you can see, it's nice green color, and that's pretty significant because that means that it's a successfully commissioned device. Now you can say, congratulations, you have created a new LON network. Now that we have successfully created a network using LON, are there some conclusions we can reach? Or said differently, are there any important takeaways about LON? Well, I think the answer is yes. The first important point is that LonWorks is still an active protocol in building management systems. I think we can all concede that BACnet has become the preferred open network in both popularity and in quantity, but that does not mean LonWorks is going anywhere. The protocol was made popular when open protocols were first brought to the market, and those users that are familiar with LON, they like it and they're going to continue to use it. And what that means is that any BMS that is using LON as their platform will continue to need support, and that means new products or replacement products that use LonWorks as their protocol. I can tell you from personal experience that the hardware, the interfaces, and the network tools are all greatly improved over what they were. So what does that mean to all of us? Well, it means that LON users today have a much better understanding of how this protocol works. That's both the system integrators and the users. So at the end of the day, that means that yes, LonWorks is different than other protocols like BACnet, but LonWorks has a place in our HVAC world. Thank you for viewing this presentation on networks using LonWorks. I hope the information will give you a better understanding of LON.